In this video, I will discuss how to calculate the sum of all divisor of a particular number. The problem is just that you are given n equal 10 and you can take any number and you have to find the sum of all divisors of it. Divisors is 1, 2, 5 and 10. The sum is 18. This is the main problem. We have to calculate this sum. Now let's see how can we calculate it. We can basically traverse from 1 to 10 and then whether between this range any number divide 10, we just sum that. 1 is divisor, 2 is divisor, and 5 is divisor, and 10 is divisor. Except this number, there's no divisor of 10 between these range. So for this solution, time complexity is just of n, but we can do better than it, because if we take any number n, at least one divisor except 1 rely on this range, square root of n. So we need to just take this number. So let's write the code. I equal 1 and I go till square root of n, that will be I into I and n and I plus plus. So we can say if n divide I divide n, then our sum, we find a divisor called I, and there's another divisor like n by I, also a divisor, so we can also sum that. By I, but there's a edge case. Suppose we talk about 36 has a divisor like 6 into 6. If we add this, we will add a particular number twice, so we shouldn't do that. So for the handle this sketch, we have to just write the extra code here, and if I into I not equal n, then we will add that. This is the square root of n solution, but we can optimize it a bit. This is the main goal of this video session. So let's see how can we optimize it. Basically, we can optimize that with prime factorization concept. Okay, suppose we have prime factorization of a particular number like p₂ and 7, 7, 1. This is the prime factorization of a particular number. Okay, so if we write the whole divisor of it, then it will be 5, 0 and 7, 0, 5, 1, 7, 0 and 5, 2, 7, 0 and 5, 1, 7, it is just 5, 0, 7, 1, 5, 1, 7, 1 and 5, 2, 7, 2. This is actually the all divisor of it. So if we sum there, then we found our answer. Okay, so basically our claim is now sum of divisor is just claim is just 5, 0 plus 5, 1, 5, 2 into 7, 0 plus 7, 1. Let's see what it means actually. If we just multiply it and there is this the expression, then we will find the all possible combination here. So if we have any number like n, then we can just prime factorization prime factorize and then find out our answer. Okay, so general formula will be like this: sum of divisor. Suppose we have a prime factor of p1 and 0 plus p p1 plus pn into p2 plus p₂ plus p₂ something like that. This is just a geometrical series, so we can write it like, and basically write it like that: e the exponent plus 1 minus 1 and this by p minus 1 will be added here. Just forget it. And so let's see how can we code it. So for I go till and to n and increment plus 1, and is the part of our code, and we can take, let's see, take first 0, then our factorization part is started, while n divided by I equal 0, then we divide n by I, and here is our counter, and we can take a d as a sum of divisor of the particular portion like this one, and we can take another one is just e, our calculate the this okay, exponential part. So for do that, and I will a exponent by I, and plus will be d plus equal, and finally our sum here, and we can take a variable sum equal 0, and we can add d to sum. And after all, if we have some spare part, like if n greater than 1, not actually greater than 1, then we can just add plus n plus 1 here. Okay, this is our actually the main part. We are not here sum here, it's my bad, actually it will be the multiplication. We're going to multiply, so here also multiply. This is our answer. Then finally we can print it. So we just reduce the execution also. Oh, that's it.